Hello students. So today we are going to start a new unit, unit 3, that is the solution of system of linear algebraic equation. Now, system of linear algebraic equation can be solved by two particular methods, direct method and indirect method. Direct method always give you the exact result, whereas indirect method will give you the approximate result. Now direct method, in your syllabus direct method will have two particular sub methods, that is Gauss elimination method and another one is Gauss Jordan method. And for indirect method you have two. Indirect method, basically it is the iteration method, that's why this is called as indirect method. And here for the indirect method you have two topics, one is Gauss Jacobi method and Gauss Seidel method. So today we are going to learn how to solve the system of linear algebraic equation by using Gauss elimination method. So today we are to start with the Gauss elimination method. So let's start with Gauss elimination method. Okay, so this is the question. Solve the system of equation by Gauss elimination method. Correct up to 3 significant figure. Now basically, for the exam purpose, always the question will comes in this format. There will be 3 given equations to you. You have to solve the system of equation. Solving means here you have to find the value of x, y and z. Okay, by using the Gauss elimination method. So the first of all, what we'll do, we will represent this 3 equation in the form of matrix. If you remember that in our that first semester paper, you have studied in a linear algebra solving the 3 system of equations by using matrix method. That means representing the 3 equations in the form of ax equals to b, where a is the coefficient matrix, x is the unknown and b is the right hand side. So here also we are going to use the same technique. So first of all, let us write the given system of equation. Solution. The given system of equations is, now 3 equations are there. The first one is 2x plus 3y plus z and the second one is x plus 2y. Now here it is your independent of choice that you can rearrange the equations. Rearranging means the second equation can be written as the first one or the third equation can be written as the second one. That is up to your choice. For simplifying, or it will help if you suppose here if I write x plus 2y plus 3z equals to 6 at the first equation, second equation as 2x plus 3y plus z equals to 9, and the third one 3x plus y plus 2z equals to 8. I have written in this format for the convenience of my solution, because if I write in this format, that it will further help me for in case of calculation part, and by doing this it doesn't affect the final result also. You can reshuffle the equation according to your independent of choice or for simplification of the calculation part, and it won't affect your final result also. So here what I have done, I have just shifted the second equation to the first one and the first equation to the second one. Now I will represent these 3 equations in the form of matrix form. So here the given system of equation, you will write that can be written as ax equals to b, where, or in the next line you can write A is the coefficient matrix. Now what is your coefficient of x here? 1. What is your coefficient of y here? 2. What is your coefficient of z? 3. Coefficient of x? 2. Coefficient of y? 3. Coefficient of z? 1. Again x coefficient 3, y coefficient 1, z coefficient 2. X is the unknown matrix. What are the unknowns? X, y, z. These are the 3 unknown variables, x, y, z. And this side b means the right hand side, 6, 9, 8. Clear? So I have represent the given system of equation in the form of matrix Ax equals to b. Now I will find here the augmented matrix. Did you remember the augmented matrix? This matrix and the right hand side. So here the augmented matrix. So notation of augmented matrix: A semicolon B. B is the right hand side, A is the coefficient matrix. What was the A matrix here? Just write that matrix again. 1, 2, 3, then 2, 3, 1, then 3, 1, 2, then semicolon. Now B means 6, 9, 8. 6, 9, 8. Okay, this is the augmented matrix. So now the calculation will be start, and you will get to know why I have shifted this x, the second equation, to the first equation. Now see, our target is that whenever you are finding the augmented matrix, in the first step your target will be make this term and this term as 0. Always the first step of the augmented matrix will be by using your row operation. Did you remember the row operations? Matrix row operation. By using that particular row operations, we will here make this 2 as 0 and this 3 as 0. Okay, let's start. Okay, so this is second row, so we will do the operation on second row, R2. Okay, so now we have to make this 2 as 0 with the help of the row 1. Just remember, the first step of the augmented matrix is making this element and this element, these two numbers, as 0 with the help of first row. So this is R2. What was the R2 term here? 2. And what is this? With the help of R1 we have to make it as 0. What is the R1 here? 1. First of all, I have to make this 1 as 2. So how to do that? We will multiply row 1 by 2. So this is now 2, this is now 2. Now we will subtract them. So this is a row 2 operation, that is R2 minus 2R1. So first of all, let us write the first row. This is the first row. Now operation here, R2, 2, then minus 2 into R1. What is R1 here? 1. So 2 minus 2, 0. For the first one, this is 0. Now for this element, R2, what is R2? 3. 3 minus 2 R1. What was the R1? 2. So 3 minus 4 minus 1. Then again R2. What is R2 here? 1 minus 2 into R1. What is R1? 3. 1 minus 6 minus 5. Okay. Now here R2, 9 minus 2 into R1. What is R1? 6. 9 minus 12, how much? Minus 3. Got it? So for row 2 we have make this element as 0. Now for row 3, now we have to make this 3 as 0. So on row 3 we have to do the operation. You can take the dash also. Now we have to make row 3, this 3 element as 0 with the help of row 1. Now what is in row 1? 1 is there, first of all we have to make this 1 equals to 3. So for that we will multiply row 1 by 3. Now this is 3 multiplying by 3, it also become 1 also become 3. Now just subtract them. So for the first element R3 is 3 minus 3 into R1. R1 is 1, that is 3 minus 3, 0. The first one is 0. You will check for the further one. 1 minus R3, 1 minus 3 into R1. R1 is 2. 1 minus 6 minus 5. Okay, now for the next one, 2 minus 3 into R1. R1 is 3. 2 minus 9 minus 7. Okay, then the last one, 8 minus 3 into R1. R1 is 6. 3 into 6, 18 minus 10. This is minus 10. So first step completed. So what is the first step? By using the row operation, you have to make this element and this element 0. First step, always. Now second step. Second step is you have to make this 5 element as 0. Only 2 steps you have to follow here. Whenever you are getting a matrix, augmented matrix, suppose I am writing A, B, C, D, E, F, G, H, I. Here L, M, N. The first step is by using row operation, you have to make this D as 0, this G as 0. Okay, by making this 2 0 with the help of first row. First step, finish. Okay, now for second step. Second step, you have to make this H. You have to make this H as 0 with the help of second row. Only these two are the step. First step, making this 2 0 with the help of row 1. Second step, making this element, this particular element 0 with the help of row 2. That is, here we have to make this minus 5 as 0 with the help of row 2. Okay. So now see, we have to make this minus 5 as 0. So we have to do the operation on R3. So let us write R3. So what is here minus 5? What is here minus 1? So we have to take with the help of R2. So first of all, we have to make this 1 as 5 because we have to make it 0. So we have to make this 1 as 5. So we multiply by 5. So what we get? R3 is minus 5. Here we have 5 and R2 is minus 1. So that is minus 5. This is minus 5. So if we put here again a minus, so there will be a minus. So minus minus plus, it will be 0. So here we'll going to put minus sign. Clear? So the operation is R3 dash equals to R3 minus 5 into R2. Clear? So let's start the operation. The first row will remain unchanged. 6 minus 3 minus 10. Second row also remain unchanged. Nothing to do with the second row. Now the third row. Okay, let's start with the third row. This is 0, this is 0. So in this is 0, this is 0. So no change. Now here R3 is minus 5. Minus of 5 into R2 is minus 1. So finally we get minus 5 plus 5 equals to 0. This is 0. Our operation done. Now first calculate this two. R3. First of all, R3 here minus 7. Minus 5 into R2. What is R2? Minus 5. Minus 7 minus minus plus 25. 25 minus 7 is 18. Positive. And for this one, minus 10 minus 5 into what is there, minus 3. So minus 10 minus minus plus, minus 10 minus minus plus 15, that is 5. So this is all about there's two steps. First step making this 2 0, second step making this 0. So we have done. Now see, from your system of equation we have converted the system of equation into the matrix, the starting step of the solution. And now from this matrix again we will convert it into the system of equation. Okay, see how we will convert this. So this is the equation, now this is the matrix. Now we will convert this matrix in terms of equation. Just remember that this is your right hand side, this is your left hand side, this is the right hand side. Now see, I will convert this from first expression. What is the first expression? 1 2 3 6. 1 means comes from x, 1x, then 2 positive, so plus 2y. 3 means plus 3z equals to 6. Okay, and the next is 0, so 0x, minus 1, minus 1y, minus 1y, minus 5z equals to minus 3. From matrix we are converting into system of equations. Now here 0x, then plus 0y, then 18 plus 18z equals to 5. So we have converted successfully into the system of equations. Or further we can write 1x means x plus 2y plus 3z equals to 6. 0x vanishes, minus 1y we can write minus y, minus 5z equals to minus 3. 0x 0y vanishes, only remain 18z equals to 5. So from this now we will find the value of x, y and z. We can see that from the third equation, from equation number 3, 18z equals to 5. So here from here we can get our z value, that is 5 by 18. So if you divide it, you will get 5 by 18 as 0.2778. Okay, so we got the value of z as 0.2778. So now this z value we can put in the second equation. So we are going the back substitution. This is called the back substitution method. First of all, from the third one we are going to find the z. We got the z value. Now we will put the z in the second equation, and from here we get the y value. So let's do that. This is the second equation. Here we are going to put the value of z. That is minus 5 equals to, that goes to that side. So if you put the value of z in the second equation, then if you simplify you will get the value of y as 1.611. So see, we got the value of z, we got the value of y. Now we will put this value of z and y in equation number 1, and from there we will get the value of x. Now see how. So this is equation number 1. So here we are going to put the values x plus 2y. Y is our 1.611 plus 3 into z. Z is our 0.2778 equals to 6. So after multiplying we get, so after putting the values and multiplying and subtracting, we got x equals to 1.9446. So we got our x here. So what we'll do, from the last augmented step, convert the given augmented matrix into a system of linear equations. We got it. Now use the backward substitution. First of all, from the third equation find the z. Now getting the z value, put in the second equation. From here you will get the value of y, and after getting the value of y and z, put all the values in the equation number 1. From you will get the x. Now the question demands for the answer to be correct up to 3 significant figure. So let us do that. So finally your x is 1.3 significant figure, that means up to this. So it is 6, it will increases by 9.45. Why? It is already 3 significant figure. Oh, 3 significant figure. I'm thinking of 3 decimal. So it will becomes as 3 significant means 3 significant. So I will write 1 point. This is 4. So no changes, 1.94. 3 significant figure, that means up to this only, 1.61. And Z, 3 significant figure, 0 will not count it. Here this is a 3 significant figure, this is 8. So 1 increase, 0.278. So this is your required answer. So got it? How to solve system of linear algebraic equation by using Gauss elimination method. This is one of the easiest method. Maximum of the time this question comes from this particular topics. So on this particular topics we will practice some more questions. Okay, so for today only this, up to this. In the next lecture we are going to cover Gauss-Jordan method. Thank you for watching. Thank you so much.